Okay, I think we're ready to start. So welcome back everyone again. This is COP-3402. Did anybody check out the video on the course website for the last lecture? No? Okay, I guess not because we're all here. I forgot to display the whole screen and just displayed a window, so you didn't get the terminal output. But I didn't make that mistake this time, so you'll get the whole screen this time around. Did everybody try? Did you try the Vim or Emacs tutorials? Anybody? Yeah? Okay, cool. Yeah. I encourage you to try them or watch some YouTube videos or something. I have some links on the website for you to look at, so I think they're fun. So today we're going to be going over the command line. So we're not going to be writing any code yet. We're just going to be using command line tools and getting familiar with navigating the file tree via the command line. So first, we're going to be using SSH. I think everybody had said, mostly everybody had said they'd used Eustace before, but in case you haven't, I'm going to log on to Eustace here. Let me actually make a new window, because sometimes I get some weird artifacts when I open browser pages from my terminal. So SSH, Eustace, and normally you're going to have to type in the entire, you'll have to do this. Your NID 095187@eustace.ecs.ucf.edu. I think that's the complete path to accessing Eustace. Let me make this bigger for you all. Yeah, I think that's better. And yeah, that worked. Enter your password and then you can log in. So this is loading. But on my machine, I've configured this to where I can just type in SSH Eustace, and it will actually log in for me automatically, just typing in Eustace. And there's a way to set this up on your machines as well, where you don't have to type in that whole NID and then path to the server and whatnot. There's instructions on the course website for how to do that. I'm not going to go over too much detail here, but I recommend doing that because it'll save you time. And remember, laziness is a virtue, one of the 3 virtues we covered last time. So let's see if this works. Oh, I'm in. Cool. So yeah, log in, enter your password. So you'll see this command prompt. The $sign just means you are at the shell, awaiting a command. And the tilde means you're in your home directory. I'm going to explain that in more detail later, but the tilde means you are in the home directory. And yeah, this just tells you what user you're logged in as, so that's my NID. So when you're in a shell, you can use commands, you can type in commands and then press enter to run them. Maybe what I'll do here is actually try to not maximize this. If there's a way I can make this window smaller. Oops. Oh, I know what the problem is. Let me try this on a different terminal window. All right. So I'm going to log in again. Try to have both the terminal and the slides open at one time. That works. I'll close this. That's better. Okay, great. So as an example, I'm going to run the ls command. Nothing here. I'll go up to the root directory and run ls. Okay. So does anybody know what ls does? Has anybody used this command before? Yeah.
It just lists all the files and folders.
Yeah. So ls lists the files and folders. And if you want to clear your screen, you can press Control-L, or you can type in the clear command. So I'll type in ls again, type in clear, clears the screen. Now, there is a bit of a difference here between Control-L and clear. So if I type in ls a few times, and then type in, and then press Control-L, you'll notice I can still scroll up, and my output is still there. But if I type in clear, it's gone. So if you want to totally clear all the previous output, you can actually press Control-Alt-L, and that will behave exactly like clear. So Control-L, Control-L, 2 very convenient shortcuts to have on hand because it quickly becomes a hassle to run commands with all this output kind of confusing you, at least I like to keep my terminal window clear. So Control L, Control L, very useful commands. So let's see what's next. Yeah, comments. When you run commands, you can prefix them with a comment with a hashtag, and that will have them have no effect. So if I were to type in ls, you see it as before, it lists the contents of my current directory, current folder. If I prefix this with a hashtag and then press enter, it does nothing. And there's another shortcut here. If I type in ls or any command, and I press Shift-Alt-3, so can anybody tell me what happens if you press Shift and number 3 on your keyboard, what character that is? What is it? Hashtag. So that's kind of the punchline. Remember, we comment out commands with hashtag, and if you hold Shift and press 3, you get hashtag. So Shift-Alt-3 is really just Alt hashtag. So if I press that, it immediately prefixes the current command with a hashtag and then enters it. So it's a quick way to comment out what you're doing, which is nice because this gets saved to your history file, which I'll be talking about later. So now I want to talk about the file system hierarchy. So right now you see I'm in this remote server, Eustace, and we're at this slash directory. Before it was tilde, which meant your home directory. Now we're at slash. So on Unix machines, unlike Windows machines, there's one root file hierarchy, root to the file hierarchy. So on a Windows machine, you might have your C drive, D drive, etc. On a Unix machine, you only have the root, which is denoted by a slash. So this information is reiterated here. And if I type in ls, or really I should type in ls-a for all. You'll notice two more directories here. So a directory is the same thing as a folder. I keep saying directory, I should probably explain what I mean by that. A directory is a folder, same thing, just different terminology. So Unix, you say directories, Windows, you say folders. The dot is a special directory. It means, does anybody know what the dot directory means? Yeah, the current directory. So let me start drawing this out maybe, to give you a better intuition. If our current directory is the root directory, oops, I'll change this color to black, there we go. You'll make the font a lot bigger. Maybe as big as it goes. Oh well. That's good. So if the current directory is the root slash, we have sort of like child directories out of here. And two that I'm going to bring up initially, let me try making that a straight arrow. Are the dot directory. And also we have another directory here, right below the dot directory on the right-hand side, which is the dot directory. Oops, not dot comma, dot. There we go. And can anybody tell me what the dot directory signifies?
It's like one above the current.
Yeah, one above, it's the parent. So you might have already been able to tell, kind of infer this information based off this diagram I'm drawing, but and also the fact that it's called a file hierarchy, but the file system forms a tree structure. So you've all taken CS1, so you should be familiar with tree structures in programming, and the file hierarchy is one such example of that. And this is not like some innate truth of the universe that file systems are arranged in hierarchies like this. This is like a design choice by humans when they designed Unix, or really the file system that Unix uses. Other file systems exist, non-hierarchical file systems, but most of them are tree-based structures. And this dot directory gives you a reference back to the parent. In the case of the root directory, there's a special exception here. Because there is no parent to the root is the highest level, it just brings you back to the root. So I'm talking about like navigating between files, but I haven't really shown how to navigate yet. And also a directory is technically a file, so just a reminder about that. You can use the cd command to change your current directory. So if I type in ls, you'll see there's some directories here denoted in blue. One of them is the user directory, USR stands for user. If I cd into user, I'm now in the /user directory. So this path here in the bottom, it's two directory names. The leading slash means we're in the root directory, and the user means we are in the user subdirectory of the root directory. So I'm going to draw that here as well. And sometimes you'll see people append a slash to the end of directory names just so they can easily tell at a glance that it's a directory and not a non-directory file. We don't need that here because we have colors on our terminal telling us what's a directory and what's a non-directory file. Okay, so if I type in cd dot, you'll see nothing happens because, again, dot is the current directory. Cd dot dot, I go back to the root directory because that's the parent of user. So let me copy these lines. I can copy those as well. Suppose not. Oh well. Yeah, that works. Okay. And I want to draw maybe some links here. Kind of illustrate what we've seen so far with using cd. So if we run cd from here, or cd dot from the root directory, we go back to the root directory. If we do the same thing using dot dot in the root directory, we go back to the root directory as well, because there is no parent of the root directory. It's a little ugly. Maybe I can fix that. Kind of, I don't know if I like this. I'll just draw it by hand. I'll polish these notes before I publish them online. I hope it gets like the meaning across, the gist of it. You can see what I mean. So in the user directory, if we were to run dot dot cd dot dot, we would go back here. Regular cd would go back, cd dot would go back to user, of course. Okay, let's go back to these slides and see what's next. And yeah, the home directory is Alex the tilde. So I could type in, if I go to my home directory, I could type in cd tilde and go back to my home directory. And you can always check what current directory you are in with the pwd command. What do you think it stands for? Does anybody know what it stands for?
Print working directory.
Yeah, print working directory. So pwd, you'll see I'm here. So if I do cd dot 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 dot, I'm in the home directory. And by home, I don't mean literally the directory called home. I mean, go back here, the value of this environment variable home. So I'm not going to get into environment variables, but this is what tilde expands to, the value of this variable here. You don't really need to know that, just kind of a clarification that I'm not referring to the directory called literally home. I mean the value of this variable home. And you could also change to that directory manually, so it's not like you have to use the tilde. I could say cd home, where is it? It was home net, I think that was it, or was it something else? All right, and that worked. I don't know why my auto-completion with tab did not work, but this works too. All right, so now there's different kinds of paths, what we've described so far. These this like navigation of the file tree, we've been looking at different kinds of paths. So again, if I run that echo command and you see this output here, that's a path. But there's more kinds of paths than those that just start with slash. So let me go back to the root directory here. Any directory path that starts with a slash is called an absolute path. You are specifying the entire complete path to a certain location on your file system. But there's also relative paths. So if I go back here, let's say I go into the user directory, and then I'll ls list out the contents. How could I navigate into the bin directory? What command can I use?
With the cd./bin.
Yeah, cd./bin. And this should take me into the bin directory. This is an example, ./bin, of a relative path, because you're specifying where the path starts from, but it's not the root, basically. If it starts with a slash, it's an absolute path. If it doesn't start with a slash, it's not an absolute path. And in fact, you actually can omit or elide that initial dot in that cd command, so bin, and that would work as well. It's implied that you mean the current directory when you were typing in an absolute path, or a relative path, I mean to say. A relative path is relative to your current directory. So if I just say cd bin, I navigate into the bin directory in my current directory. And this will be on homework for until next lecture, the difference between absolute and relative paths. You should know that. Just remember, absolute paths begin with a slash. Relative paths do not begin with a slash, and they're relative to the current directory. That's all you need to know. And how can you check the current directory? What command? pwd, yeah. So we went over this. Parent directory. So if I wanted to go back to the parent directory and I didn't have access to the ... directory, how could I go back to the user directory without using the parent directory? ... Yeah, well, not /home, because I'm not in the home directory, I'm at the root. Yeah, cd/user. So I could just do that, so cd hyphen is like a shortcut, taking me back to the last directory I was in. You don't need to know that, but it's just another fun shortcut. I know a lot of these, and I'll be like littering them throughout the lectures. You could also say cd ... or just cd ... and that will take you back to the parent directory as well. So this is an example of why we actually want to have that parent directory, that ... reference, because it is a convenience. Otherwise, you'd have to type in absolute paths whenever you want to get anywhere, and that becomes a headache very quickly when you have long paths that you're navigating through. Okay, let's see. So we went over this, pwd, that's the directory, ls. So I kind of want to illustrate something here, though, that may not be entirely clear, that sometimes confuses people. There's a difference between, so you are on the shell when you are typing commands. You are in the bash shell, born again shell. But there's a difference between commands and built-in shell commands. So if we go into the user bin directory, you'll see the name of a bunch of different programs here. These are all executables on your machine, and this user bin directory is a special directory. I won't get into why it's special, but it's a special directory in that if you type in the name of a command to run from your shell, bash, the shell you're running, will actually look in the user bin directory for a name of a program that matches the name of the command you typed in, and will run that command from the user bin directory. So you don't have to type in the whole path to user bin. So how many of you have ever run a C program before by typing / in the name of the C program that you compiled? So you're familiar with that. This is a convenience that lets you omit that path to the C program. So what you're doing when you're running ./hello, if you're running hello world, is you're specifying the path to the program you're trying to run. But you don't have to specify the whole path to it if it's in the user bin directory. And for an example here, there's actually a program. So if I type in ls and the name of a file afterwards, it will actually restrict ls's output to only the name of files that match the specified name here. The ls program itself is in this user bin directory. And that's all to say, some commands are not really commands though. Some commands are built into your shell, and this is done for optimization, for performance, because it's faster to run, and we're actually going to learn why it's faster throughout this course. It's faster to implement some simple commands as shell built-in functions rather than implementing a separate program and then forking off a process to execute that program and giving execution back to the shell. And the way you can check whether something is a built-in shell command or a external command is to use the type command. This is not going to be something that I'll ask you on an exam, but it's very useful to know this when you're trying to get help for how a command works, especially if you have both a command and a shell command that are named the same thing. So if I type in type and then -a to list all the types of a command, you'll see that ls has an alias, which is like a shortcut for a command name. It appears in user bin ls and bin ls, so it appears in multiple places. The one at the top is the one that we actually use by default. Likewise, if I type in type-a pwd, pwd is a shell built-in, but it's also a command. But the shell built-in gets called by default first, because it's the first one on the list. So any questions so far? Yeah? So there are different bin directories. So user bin is for binaries. So that's what bin stands for, binaries, executable specifically, because there are binaries that aren't always executable. Those are libraries. For executable binaries that are installed by, I believe, your system administrator. I believe /bin is for default binaries. There's actually a link in the website of the Unix file hierarchy. There's like a standard that Unix systems are supposed to follow, and it tells you what each of those bin directories are supposed to have in them. I think this is right. If somebody knows like what those different file directories are supposed to mean, please raise your hand and tell me. But I believe user bin is for packages installed by users, and /bin is for those installed by default on your machine. And there's also like other bin directories you can install, like in your home directory, you can create your own bin subdirectory there and have custom binaries just for your user. I don't know, does that answer your question? Okay. So the reason I show you this, the shell built-in versus the user bin, or external commands, I should say, is because there's ways to get help when you're running a command. And there's two primary ways to do this. If you're running an external command, so like we saw ls, there's none of the ls things here are shell built-ins. They're all in user bin ls, they're aliases, etc. You would run the man command. Man stands for manual, and then followed by the name of the command you want help for. So if I type in man ls, I get the man pages for ls. This gives me information on like brief synopsis, how it works, the description of the arguments or flags, and return values, etc. There's more information on here. I recommend reading these, at least skimming some of them. But you'll notice if I type in man, well, this actually would work, but I can type in man pwd, and that will technically work, but this is not the command that I want. This is not the one. This will give us the man pages for the bin pwd, which is not what we want. We want help on the built-in pwd because that's what is the first one here. And the way you do that is with the help command. So help pwd actually prints out information on the shell built-in. So help is for shell built-ins, man is for external commands that are in your user bin directory, and etc. Again, you won't necessarily be tested on the help command. I'll probably ask you questions on man, but not on help. But I recommend just knowing this because there will be times when you're trying to look at the man pages for a command, especially like the time command. This is a command that frequently on Unix machines, exists as shell keyword and also an external command. And it's really annoying when you're reading the man pages trying to figure out how to run this command, but when you're reading the man pages does not match how the command actually works because you're actually running the shell built-in, not the external command called time. So just as an example, it's good to know the difference between when to use help versus when to use man. Yeah, so you've seen CD. If I run type -a CD, you can see CD is just a shell built in. So if I type in man CD, there's actually no manual pages for it. You have to type in help to get help for how CD works. And there's actually quite a few options here, and a description of all the different like environment variables and whatnot that affect how CD works. So yeah, parent directory, subdirectory, over that. So there's ways to actually move very fast on the command line. And one of these ways is to use, by the way, I hate this image, it's AI generated. Like, it doesn't make any sense. You can see one of the wheels isn't even touching the ground. But the idea is correct in that there's ways to go very fast in the command line. And one of these is to use tab completion. So who uses tab completion? Okay, I hope by the end of the semester, everybody will raise their hand. Like I said yesterday, one of the promises I made, like the very first thing I said was that I promised you to be better as a software engineer. One of those things that'll make you so much better is to use tab completion. Like it's like one of those easy life hacks that actually work. So if I type in, you might think like I'm typing commands really fast up here, but I'm not really. I'm actually not like that great at typing all the time. If I type in, let's see here. What's like a long directory name? sbin.user is merged. No, non-existent. That's a good one. So that's a long directory name. I could type in non-existent, and then that would work. Oh, I guess it doesn't work because permission is denied. What's one I can type in? Yeah, okay, so I can use that one. bin.user is merged, whatever this directory is. That's like a long command name to type in. So I could type in the whole thing, bin.user is merged. But what I could do instead is type in bin dot, and then because this is a unique prefix, let me type in ls again so you can see, no other directory or file in this current directory begins with the prefix bin dot. If I type in bin dot and then press tab, the shell will automatically complete the rest of my command for me. This is a huge boon. You go so much faster when you use autocomplete. I strongly recommend getting in the habit of just spamming tab. Like, don't worry about it. Now, if I were to type in just bin and press tab, you'll notice nothing happens. But if I press it again, you'll see why. It's because there are multiple directories in my current directory that begin with the prefix bin. So the shell spits out all the current files or directories in my current directory named bin, and then asks me, which one do you mean? There's several. This also helps you catch typos, because if I were to type in bin.user, yeah, I'll leave that, bin.user, and then I try to press tab to complete and nothing happens, that's a hint that I have a typo. So remember yesterday we had said one of the virtues of a great programmer is hubris, being able to write programs that don't just seem to be prepared for user desires, but anticipate them. This is an example. It's anticipating what you want to do, move around the directory tree fast, and so it's enabling you to do that by using tab completion. Yeah, so these are all good reasons why. Let's move faster. You don't have to remember file names entirely, just remember like the first letter. So one thing I like to do when I'm creating a directory with files and folders that I think I'm going to be accessing frequently in the coming weeks, I try to give all the directories names that begin with unique letters. So I only have to type in one letter and then can press tab and immediately go to the directory that I want when I'm typing CD, etc. Yeah, so let's just demonstrate this. User include. So how I said user bin is for user installed binaries. It might be admin installed binaries. I might be wrong there. User include is for user installed or admin installed headers. So if I type in ls, you can see there's all sorts of .h files, C header files. These are like the public APIs for packages you install for your C programs. So if I type in GNU and then press tab, it doesn't actually work because there's multiple GNU things here. GNU make, yeah, autocompletes like we saw. So I recommend practicing this. Like, I don't know if any of you have done martial arts before or any kind of activity which involves a lot of physical repetition. You have to do drills and exercises, and like katas are another name for them. This is kind of similar. You have to just practice these commands again and again and again, hundreds of times. Probably not hundreds for simple ones, but up to hundreds of times before it becomes literally muscle memory. You're not even like thinking about it, you just do it automatically. I don't know if you've ever heard of like the 10x engineer. I don't know if I believe it, but like this is one of the things that a 10x developer who moves 10 times faster than a normal developer does. They use tools like this, like auto-completion tools. Okay, one more thing I want to show before we get on to these shortcuts. Some of you might be used to using GUI interfaces for navigating file systems, and you want to see a tree structure. There's a way to see that. There's a thing called a tree command. So it's spitting all this out. I'm going to cut it off before it finishes because it's trying to print everything in the system. But it basically outputs a tree-like output, or the tree structure of your current directory, or the directory you pass to it. So if I type in tree and then tilde, it will print out the tree structure for my home directory, which is nothing because nothing's in there. But if I type in tree, let's see, home, and then net, well, I guess I don't have permission to access that entirely, so I won't do that. How did I make a directory? So I'm going to use the make dir, which I think is a shell. No, it's a command. Okay. So make dir, I'll make a directory called, I don't know, foo, and cd into foo. I'll create a file. So touch command creates a file. I'll explain all this more later. Var, and then touch var /baz.txt. Now if I run tree and then pass it the current directory, it will actually print out the directory structure that I've created, which is another thing we're going to be using for one of your assignments. You're going to be using the tree command you're going to be looking at the output of a tree command to look at a current directory structure, running some commands to rearrange the files in that structure, and then running the tree command again to print out the new structure, and that's one of the assignments you're going to be having in this class. And like other commands, you don't need to pass the current directory to tree. Implicitly, it will assume that you mean the current directory. Okay, any questions so far? Okay, so now I want to talk a little bit about other shortcuts. So there's more shortcuts than just tab. Tab is like one of the ones you'll use most frequently, but there's other ones. And another reason to actually, see if I can zoom out here, okay, to read the Emacs tutorial is because on the command line, it uses Emacs shortcuts by default to move around. I prefer to use Vim for editing, but since the command line is basically all just insertion, it's helpful to know some Emacs shortcuts because they're a little bit faster on the command line than Vim shortcuts would be. So let's say you're typing a command. Let me see, what command could I type? // tab, see the current directories here, okay. User, bin, all right. I could press the home key on my keyboard to go to the beginning of the line, but that's a little bit of a reach depending on what keyboard you're on. I mean, if you look where your home key is in your keyboard, it might be a small key, it might be off to the side. It's not immediately accessible. What's a little bit easier, I'm gonna press the end key here, is to use Control A. So you can think like the mnemonic is A is the first letter of the alphabet. So you go to the first character on the line, Control A. It takes you right back to the first character of the line. Likewise, or similarly, Control E goes to the end of the line, so E for end. Control A beginning, Control E for end. So these two shortcuts are pretty helpful, I'd say. Backspace deletes one character, naturally, but Alt backspace deletes one word, separated by slashes. So if you're typing in a directory path and you made a typo, or you don't want to go to the full path you were originally specifying, you can hold Alt and press backspace and go back one delete one fragment of that path. And if you want to delete the whole thing, you can press Control, this isn't listed here, but you can press Control W. And that deletes a whole word, where a word is one contiguous sequence of characters. Okay, let's type in some of that again. Now, you can press Alt-B to go back a word, Alt-F to go forward a word, so B for back, F for forward. And again, these are just faster than using the arrow keys. You could use the command, like Control arrow keys move around too. But that's kind of, the arrow keys get a little slow at times when you're typing commands on your main keyboard. The arrow keys are always off to the side. So it is just, again, a little bit faster to keep your hands on the main keyboard, like main keys, home row, near the home row, and use Alt-B, Alt-F, etc. And there's also control alternatives, like control variants for all these. So instead of Alt-F, you can say Control-F, Control-B, Control-F, and they go forward and backwards one character instead. See what else is here. Okay, so if I say Control B, oops. So you can use Control D to delete a character in front of the cursor, kind of like the delete key on your keyboard. I don't know if you've ever used that before, but it deletes in front versus backspace. Control F, or Control, what is here? Alt-D. So Alt-D deletes a word in front of the cursor. But I don't typically use these. What I typically use, actually, is these two. I use Control-U, which deletes everything before the cursor, and Control-K, which deletes everything after the cursor. So one small tip, if you're typing your password in, you might have noticed that on Unix, your password is blank when you're typing it in. That's a security measure, so nobody can look over your shoulder and see what you're typing. You might accidentally type some things in when you don't realize, like before you get the password prompt, if you're logging into Eustace and there's some delay. You can just like smash your backspace key to try and hope that you're deleting all the extra characters you typed in. But a better way is to just press Control-U once. And that way you're sure you've deleted everything before you type in so far. So it's also just a faster way to like kind of clear your buffer when you're typing in your password. So yeah, so Dr. Gazillo had written Control-K, but I think he didn't know about Control-U. Maybe he did, but they're not here. Control-P? No, Control-P doesn't do that. Yeah, I know what Control-P does. Let's see. Oh, okay. So I don't use Emacs, I use Vim, like I've said, so I'm not familiar with all the Emacs shortcuts. I should be. Control-Y will paste. So when you delete something, you frequently get it, it's not really deleting, it's more like cutting on your keyboard. So when I'm typing Control-U, it's actually cutting things to my clipboard. And then you can press Control-Y, to paste that. So let's see if I type in ABC. I think this will work. Yeah, ABC. And then Control-Y, it'll paste it in. So these shortcuts all work for Emacs. So that's an incentive to go for Emacs, I guess, instead of Vim or whatever editor you want to use, is that you'll have using the same shortcuts on the command line as you would be using in your editor. Okay. This one's good. History. So does anybody use the history feature when they're on the command line? Like what? Like the up arrow, right? Yeah, okay. So does anybody use the up arrow when they're on the command line? All right, that's good. That's good. So the up arrow is a good way, again, to save time. Another thing that like 10x developers do. The up arrow will just bring you back to the previous command you've entered. This is another reason why it's good to use that shortcut I mentioned earlier, Alt hashtag or Shift Alt 3. Because then if I press up arrow, that command is right there. So I can go back and edit it again without having to actually run it. If I'm working on a command and I haven't finished it yet, but I want to just save what I have so far. History command prints all the commands you've run previously. you can actually change, like if you type in help history, because I believe, yeah, history is a shell built-in, not really an external command, it's a shell built-in. There's information here on how you can modify how your history works. You can add like timestamps, you can specify how many commands you want to save in your history. I recommend making a history file pretty big so you can save a lot of commands because you never know when you're going to want to run a command again. And you can use the up arrows, but again, I don't really use the up arrows when I'm typing in commands. I tend to use Control P because you don't want to reach for the arrow keys. Keep your fingers near home row so you're typing faster. So Control P also works for going back. P stands for previous. Control N goes down, so N stands for next. Previous, next, that's the mnemonic. Does anybody use that? Control P, Control N? No? Okay. Hope you try it. It actually feels pretty good once you start using it. And again, this is something you'll see in Emacs. I think it goes up and down lines. I can't remember. But this is also an Emacs shortcut. Another really powerful one is Control R. So does anybody use Control R? Yeah? One person? Okay, good. Well, not good. I wish more people would. Control R lets you do a reverse search. So let's say, let me actually clear this here. My last command was help history, but let's say I wanted to run that tree command I typed in earlier. I could just like mash Control P and go all the way back there. Or I can type in Control R, type in tree, and then the first command that has tree in it will appear. And then I can actually type in Control P again and it will actually go back to the previous match. So it's a little bit faster, especially if the command you want to run was like days ago, but you like kind of remember that you ran this command and you kind of remember what it started with or some of the text in it. It's really better to use Control R instead, so you can reverse search your history. And yeah, be careful because if you do see like a command you want to run and press enter, it will actually run that command immediately. It doesn't autocomplete and then bring you back to the prompt for typing in more stuff. It immediately runs the command. So just keep that in mind when you're reverse searching commands. And one more thing that I want to bring up that is not in these slides, there's another shortcut for history. Let's say you have multiple commands that have the same search term in them. So you can see I have this commented out tree command, but I also have in my history this tree command that did not have a comment in it. And I want to run the first command that has begins with some prefix, so in this case tree. You can actually type in exclamation point and the name of the command you want to run. And this will do a reverse history search for the first command that begins with the prefix after bang, and then run right away. Another really cool one, let's say I type in ls/, maybe let me go back to my home directory here. ls dot pwd, okay. Yeah, I'll type in ls. Think of how I can give this example. Okay. This one's a little bit weirder, but it's kind of cool, so I'm gonna show it. It's one that I think is kind of a little lesser known trick. So if I type in a command like touch, I don't know, buzz.txt in ls, you'll see this file has been created. There's a way to actually rerun a previous command and replace some part of the command with a new piece of text. So the way it looks like is kind of weird. So I would do this, buzz.txt, another caret, and then fizz.txt. Let's just say that. And what this will do is rerun the previous command, replacing the matching pattern with the one in between the first set of carets with the one on the right-hand side. So if I press enter, oops, that didn't work. Maybe it's not the name of the command, but so let me try this. pwd touch cat. Oh, I know why. Because now I have other commands in my history. Yeah. What? Yeah, I did ls afterwards. Okay, you know what? I'm not gonna go over that one. It's not gonna be in the test anyway, so maybe it's too much. So I won't go over it. Kind of nerd sniped myself. So yeah, you can save commands by putting the comment in front of them and entering them. Now I want to get into some more useful commands for looking at the contents of files. One of these is cat. So let me go back to the root directory here. Let's see if there's a file here. ajquota.group. Let's see if I can cat that out. No. Let's see, is there anything here I can look at? Okay, what I'm going to do is log out of Eustace, and I'm going to open a new window. This time on my own machine here, so I'm not in Eustace, I'm on my own machine. I run the same operating system as Eustace uses, so it should be the same. I'll go into the directory I've created for this class. You can see it's kind of long, so it's a good thing I have auto-completion with tab to get to there quickly. Let's see. cd org, and the cat command, when you run it, will print out the contents of the file you pass to it. So if I type in commandline.org, which is a org file, it's like an Emacs file extension, it'll print out the contents of this file. Does anybody know what cat stands for? Yeah, concatenate. So what does concatenate mean? Yeah, put together, two strings particularly. So if I type in cat and then let's say homework, homework1.org, homework2.org, it will actually print out the contents of both of these files in sequence. This is useful if you want to combine multiple files into one. But typically people just use it to print out the contents of one file. Another command, one shortcoming of that cat command is that it prints all the contents out to your terminal right away. And you saw when I was trying to scroll through this output here, it's like really slow, really painful to watch. Instead, you can use what's called a pager. So a pager will print out some output and then prompt you to step through the rest. So I could say the same thing, print out homework, homework2.org, and now I can kind of step through this one piece at a time. But there's a shortcoming with more. More does not let you go back. So if I press the up arrow, it takes me back to the head of the file. It doesn't just let me go up one step. Like I can't go up, I have to go back all the way to like the home essentially, or maybe I'm paging up. Yeah, okay. More typically does not let you go like backwards. The command you want to use for going backwards is less. So the joke is like less is greater than more, less is more. So if I type in less homework2.org, now I can go up and down, and I can even use Vim shortcuts, actually. So J and K and Vim let you go down and up, respectively. You can easily scroll through files with less. And this is good to know because some Linux machines only have more and maybe less installed by default. They don't have like certain editors installed, so a good way to like page through files is to use just more and less. And you'll use Q to quit, yeah. For some reason this is frozen. Let me try closing my browser windows and reopening them. Okay, that seems like it's working now. Okay. Yeah. One cool thing you can do with with less is if I type in less homework1.org. I can type in a slash, and that brings me into a search mode, and I can search for a string. So I can type in Linux, and you can see it's matching there. And then I can type in N to go to the next match, but there is no next match. So maybe I'll type in, I don't know, just SSH. And you can see every time I press N, it brings me to the next match. This comes from Vim. So if you're using Vim, that's a Vim shortcut that has been inserted into less. And yeah, capital N goes back. You can see all this in the webpage. I'm going to leave that for now. Oh, one cool thing here. If you're editing a file, so let me just create a file really quickly, kind of show this. I'll create a file. I'll say vim main.c, and I'll just create a hello world program. Okay, so this works, but it's kind of painful. If I want to edit this file, I have to quit it, save and quit, make my changes, and compile and rerun. And I have to restart Vim every time. And Vim is pretty fast, so it's not really that much of a problem. I'm using nvim, but I'll just use Vim here. It's actually still in Vim, but oh well. It's not really much of a problem. But one thing you can do to quickly exit your editor when you're on the command line is press Ctrl-Z. And what this will do is suspend the editor. It's still running. You can see it says stopped here, but it's still running in the background. It's just not actively in the foreground of your terminal taking input from you. You can reopen it by typing the FG command to send the previously stopped command to the foreground. So if I type that, it opens it up again. So I can press Ctrl-Z, and I can type in my compile command again, which I'm not going to type in manually. I'm going to use history to go back to it and run it. And then I can run my file again. So this is kind of like a tight development loop, not really that tight. There's ways to go even faster than this. You can like map compilation to a keyboard shortcut in Vim or in Emacs and then do that, and that'll be really fast. Yeah?
Does this only work for editors or other programs?
Other programs too. If they're running and you press Ctrl-Z, it suspends it, puts it to the background. And then you can type in FG to bring it back to the foreground. And I think FG is, yeah, it's a shell built-in, not an external command. It's a shell built-in. And another command that I want to bring up is, because it's similar actually, similarly named, this just reminds me of it, is FC. FC actually opens the last run command in your terminal in your editor of choice. This is really great because typically when you're on the command line, you may not be that well versed in all the shortcuts to move around. And you might, like for example, I use Vim, but the command line shortcuts for moving around are Emacs shortcuts. So for me, if I want to like manipulate a really long command, I would type in FC, it would open up the whole command in the command line, and then I can make my changes. I don't know, I could like paste this a bunch of times. Do whatever I want, like here. And then when you save and quit, it will actually run that command when you save and quit your editor. So I typed in echo hi, echo just prints out what you give it, so it just echoes hi to the terminal. So next thing I want to do here is quickly show you how to get started on the homework. So the next homework is going to be, I've updated this link, but it's not reflected in the slides. To download a tarball. So a tarball is any file that ends in .tar. It's like a compressed, kind of like a zip file. Have you ever seen those before? Like a compressed archive of files into one single file. Let me see if I can get the correct link here. Actually, I'm going to use this FC command as well. So let me, actually, another shortcut that I want to bring up is Control-X, Control-E, and this will open an editor window that's similar to FC. It opens in an editor of your choice, your default editor, and when you save and quit this buffer, it will run whatever command you typed in. So Control-X, Control-E. The idea is execute my editor. That's like the mnemonic. Control-X, Control-E. So in here, I'm going to type in this command that is in the slides, and I'm going to try and change the link. Oops. To be the one for this course. I haven't updated that one, so it's for the previous course. And I think that's the correct command, so let me try this. And unexpected EOF. Oh, I forgot the single quote here. There we go. So wget stands for like website get or web get. It will download a file from the internet. So you pass it a link to a page or some file and it will download it for you. You can see it have a little progress bar here. It completed immediately because there's not really much to download. And there's this directory or tarball here called homework2.tar. So like I said, tarballs are like archive files. They're compressed. They have a bunch of files inside them. The way to unpack them is to use this tar command. So tar xvf. So tar is like kind of arcane. You have to know all these different sequences of letters to get it to work. But the one you'll use most frequently is xvf. So what it stands for, there is a mnemonic for this. X stands for extract. The V stands for verbose, so print all the files as I extract them. And then F stands for file. I'm going to pass a file name after xvf that I want you to extract. So I'll type in tar xvf, and you'll notice that when I press tab, it didn't even prompt me for what file I wanted. The autocompletion is sophisticated enough to know that since I'm running tar, I must want to autocomplete to a tarball, a tar file, to decompress. So when I press enter, you'll see it actually prints because I passed it that V flag, VF, or V, I should say, all the files that were extracted. When I navigate into here, the contents of the directory are all unpacked for me, ready to edit. So editing the file tree, touch, I kind of hinted at this earlier. Touch just creates a file, just creates a new file for you. So if I say, let's see, touch main.c, there's a main.c file here. rm, so rm removes a file, so I can remove that file I just created, main.c, and I think rm, okay, so it's not a shell built-in, it's a command. What if I want to remove a directory? So let me go back to, I'll also leave this right here. Let's say I want to remove that net directory. And I try running rm on it. That doesn't work. It says it's a directory. Okay, well, let me read the rest of the slide. I see rmdir, remove an empty directory. So if I run rmdir on net, it also doesn't work. It's not empty. So how can I delete a directory that is not empty, that has contents in it?
Wasn't like dash R, like the recursive?
So dash R, yes. So you use rm dash R, oops, R, and then net. And that will remove the directory recursively. So can anybody tell me, let me see if I can delete some of these. I guess I can't because I closed this. But since we know that directory structures are trees, what is like an algorithm for recursively deleting a directory structure?
Traverse the child nodes of the files, delete each one, and then traverse back to the parent.
Yeah, so that's post-order traversal, right? So again, stuff from CS1 is carrying over here. I think you might have to implement that in this course as one of these projects. I can't remember. But you will have to navigate file trees. Yeah, so dash R for recursive if you want to delete a directory that's not empty. So you can actually move files around. So say I want to move this make file into the HID directory. Let me just make sure there's none in there already. Okay, there's no make file in there already. I can do mv makefile and then HID, and this will actually move the makefile into the HID directory. So now if I type in ls, it's not here, or if let me just type in the tree command, you can see. There it is, in the HID directory, right here, this one. Let me put it back. So HID makefile dot. Okay. How do I rename a file? What? Yeah, move. So I can rename a file by moving it to the name of a new file. So I can move my makefile, mv makefile, to makefile lowercase like this, and now it's renamed to makefile. So mv is kind of serves multiple purposes here. It's overloaded. That's how you rename a file on Unix systems. You'll use mv. There's also cp, copy. So I can run cp makefile and the name of the directory that I want to place it in, or the name of the file I want to rename it to. So if I pass it a directory name like fs and then type in tree, you'll see there's a copy created in the fs directory. So just like there's also rmdir, there's also makedir. I think I used this one earlier to create a directory. I hope a lot of these names are intuitive. The only one that's not really is touch. I just think it's kind of funny though. It's like touching a file. I don't know. Also, the reason why it's called touch is because if a file already exists, you can still pass it to touch, and what that will do, let me see if I can show this without it being too weird. If I run the stat command on a file, you'll notice this. Let me actually cut the output here. Stat dash. Oh, I know what the problem is. Okay, I'll just say stat makefile. Okay. There's this access time when the file was last accessed. This might be of interest to like sysadmins and whatnot, knowing when like certain files were last accessed on a machine. You can actually run the touch command on a file, and that will update the last access time. You can see the access time has been updated now on my machine. So that's one reason why you want to use touch on a file that already exists. And that's kind of why it's called touch, because in a sense you're like touching it, updating its access time. But if it doesn't already exist, touch will just create the file for you. But the other names I think are pretty intuitive, pretty logical. RM, remove, move. You can see like Dr. Pizzillo had outlined the mnemonics here. So we had went over this, the algorithm for removing contents of a directory. So review, yeah, pwd, ls, moving around using cd. So again, you can use that cd hyphen to go back a directory. And there's actually another way to navigate around directories that is not mentioned in these slides that is sometimes very useful if you end up writing bash scripts yourself later on. So there's ways to bash scripts are scripts you can run to run a sequence of bash commands in order. One command that's useful when you're writing those scripts is called pushd, push directory. So if I go back to my home directory here, I can say pushd desktop homework 2, and now I'm in homework 2. But I can then run pushd as well, again, to go back to, let's see here, my root directory this time. What's that noise? Thank you. popd lets you pop, so you're pushing directories to a stack essentially, and then popd lets you go back to the last directory you were in. So I can run popd twice and keep going back to my last directory. This is different from cd, so I could also say cd desktop homework 2, and then cd hyphen to go back. But this only lets me toggle between two separate directories, cd hyphen, back and forth. Pushd and popd let you create a stack of directories. So another data structure from CS1 that you should hopefully all remember is a stack. You can kind of push directories onto a stack and then go back. And these are shell built-in, so if I type in pushd, you can see it's here. And there's a way to view the contents of the stack. Yeah, dirs. It tells you the current contents of this directory stack. And if you have nothing in here, it's just the current directory. So again, I could say pushd hyphen pushd user bin pushd desktop homework 2 again. And then you can see it's actually printing the dirs for me. This is the current state of my directory stack. So this is also useful when you want to go to a directory, make a bunch of changes, and then immediately go back to the directory you were in previously. You can just do popd to go back. So popd, popd, popd. Tab completion, I've been using that the entire time. History, control up, or up, control P, control N. All the commands we just went over. So much for commands. I want to try and fix that one command that I was trying to run earlier that I couldn't get. So let's see. If we have ls makefile, I think it's cat ls cat like this. There we go. Yeah, so there's nothing in this makefile. Yeah, it's empty. So what this does, these carets, the sequence of characters between the first set of carets is the pattern you're searching for, and the one after is the pattern you want to replace with, and it will do that replacement on the last command you ran. Sometimes that's useful. It's kind of like a bit of like a trivia, but sometimes it is useful to know that. So if I'm running like, I don't know, let me think. If I say tree HID, I could say this HID replaced with FS, and then it will run tree again, but with the FS argument instead. So again, not something like you need to know, but it is kind of cool to know that one little lesser known trick. If you can't tell, I've read the bash manual, so sometimes I just like to show the things that I saw from that. So I guess that's it for class today, or all the commands I wanted to show you. If you have questions, please ask me. The next homework is up, it's published, you can start working on it. The web course submission is just text. Yeah.